Okay, so the focus of chapter 4 is on solving equations, but we are going to merge a little bit of solving equations with some of the linear relationship stuff we've been working on from chapter 3. And the whole big plan is to bring it all together in chapter 5 quite nicely. So today we're going to use some of our linear equations and algebra skills to find parts of a linear relationship. So the slope, the intercepts, table of values, those types of things. So we're going to put it in action. Okay, so just a quick review of linear of what we've covered so far. So we talked about partial and direct variation. So you've seen partial a lot. You might notice that direct variation is just partial variation with a plus 0 there. Okay, I'll make that a little... Okay, so they're really not that different. Partial variation is probably the more universal way to look at linear relationships because it can take care of a whole bunch of things. Direct is fine as well. You just have to remember that the b is actually 0 and they tend not to write it. Okay, so I'll just get rid of that for now. M is the slope. And there's a couple names here, so we should make sure we list them all. So slope is 1, rate of change is 1. You might also find it called a multiplier. That is another option. Okay, B is the y-intercept. It's also called the initial value. Okay, and this could be dependent on your textbook, on who's teaching, a whole bunch of things. So just keep an open mind that the slope is a rate of change, it's multiplier, the y-intercept is initial value. There's lots of different ways to express these things, so just keep an open mind. Okay, slope or rate of change describes how the x and y variables change. Okay, so if the slope is 2, there's a placeholder of a 1 underneath that, and that's a rise of 2 versus a run of 1. That means the y value is going up 2 for every change of 1 in the x value. Okay, this is all should all be review. If not, go back and rewatch the slope video. X-intercepts have y values of 0. Okay, so you can see here, this is my x value, here's the y of 0, and y-intercepts have x values of 0. I need an S in there. Okay, so this would be a y-intercept. So here's an example. We can see right away this is partial. Okay, and we should be able to interpret a few things very quickly. We should be able to see the slope. There's that m value right there. It's the multiplier in front of the x, so the slope is 5 over 1. And the y-intercept, okay, comes from this term, including the sign, 0, negative 7. Okay, so we're going to build on that knowledge today and add a few other pieces. So graph the following linear relation using a table of values. So there's a couple ways to do this, and this is where lots of people get stuck, is if you're given an empty table of values, a lot of people don't know what numbers to choose. You could choose anything you want. Most people, though, or what you'll find it makes it the easiest to draw, is you pick numbers around 0. So you might pick 0, 1, 2. Okay, and the minimum you need to have is 3 points. 4 is better. Okay, so I'm going to choose those 4 for now. And you can do this a couple ways. So I'm going to show you one way, which I'm not a big fan of, but you might like, so I'll show it to you. You take the original expression, so 2y plus 4x equals 10, and then you substitute in your numbers. So let's start with 0, because that's a nice number to start with. It would be 2y plus 4 times 0 equals 10. 2y equals 10, because 4 times 0 is 0. Y equals 5. And then you would write the 5 in here. Okay, now what you might notice, though, is for each one of these values, you're going to have to do that calculation. And that starts to be a bit of work. So what we can do is we can cheat a little bit, and we can do our algebra first. And what's really nice with doing the algebra first is it makes it a little easier to solve later on. So I'm going to take this expression, and I'm going to isolate the y value. So I'm going to try and do all of my algebra right at the beginning of the problem. Okay, so I don't quite have the y value by itself yet. I need to divide everything by 2. And now I have y equals negative 2x plus 5. Okay, and what we might find, Now, if we tested this question again here, if I put a 0 in here for the x, negative 2 times 0 is 0, plus 5 gets me back to 5. So I found that value twice using two different methods, so I'm pretty happy with that. Okay, and once this is rearranged so that y equals the expression is by itself, it becomes really easy to substitute in the other numbers. Okay, so if I put, let's go up to the negative 1. If I went negative 2 times negative 1 plus 5, I would see this becomes positive 2 plus 5. I would get a 7 here. Okay, I'm just going to erase some of those so I have enough room to keep writing. Let's do red. Okay, let's go for the 1. Y equals negative 2 times 1 plus 5. Negative 2 plus 5 would be 3. And then we can do our last value. Let's use purple. Y equals negative 2 times 2 plus 5. And that would be negative 4 plus 5, or just a 1. And the reason I suggest you do at least 3, preferably 4, is because you can start to see a really clear pattern of how these are changing. And if you only do 1 or 2 points or 3 points, sometimes you can make a little error and you can extend your pattern incorrectly. If you do 4 points, very seldom will you get caught by that. So you can see these guys are all going down by negative 2. And that shouldn't be a surprise because we were told this is a linear relationship, and that's our first difference. Okay, so at the same time, I'm just going to come over here and I'm going to just check something else. I'm going to see how these guys are all changing. They're all changing by plus 1. Okay, so now there's a couple things I could use that information for. If you recall, monitoring how the x and the y values change, okay, that's one way of finding slope. So there's one location to find slope. So let's grab our pen again. So we now know from the table of values we have a slope of negative 2 over 1. If I was to plot this line, so if I plot all these points, if I put a dot there, there's a dot, 1, 3, whoops, got too close to the board. Okay, and then here, here, here. And now if I investigate how those are changing from a picture standpoint, you can see that's down 2 and right 1. So I have negative 2 as my rise and positive 1 is my run. So my slope, and I'm going to use just the little m here to save space, negative 2 over 1. Hey, that's the same as what I got here. And if I went back and visited my equation again, oh my goodness, there's my third location to find slope, and I still get negative 2 over 1. Okay, if I'm looking for my y-intercept, just for conversation piece, there's my y-intercept. And if we read that location, we would see that is 0, 5. If we were still looking for our y-intercept, we could also find it right here from our partial variation, and we can also find it right here. So even though the question didn't ask for it, we might as well just talk about it for a minute. So the y-intercept is 0, 5. Okay? All right, find the x-intercept, y-intercept, and the slope of the following line. So method 1, table. Now again, I might find for myself, I would probably rearrange this expression because I find that easier for my brain to work with. So I would try and get the y by itself. So I would add 9x to both sides, and then I would divide both sides by 3. Okay, so now I have y equals 3x plus 4. Okay, so now if I wanted to do a quick table of values, again, you choose the values. I'm going to choose 0, 1, and 2. Okay, so if I punch in those numbers, I would have y equals 3 times 0 plus 4. That would be a 4. Y equals 3 times 1 plus 4. That would be a 7. And then lastly, y equals 3 times 2 plus 4. That would be a 9. Okay, and if I do a quick check, not a big surprise here. These are all changing by 3. This side is changing by 1. And we just talked about, is that my slope? It's 3 over 1. If we come back and look at our equation, do I have a 3 over 1 as a multiplier out front? Yes, I do. Okay, so we've found our slope already. I could graph this as well. That's another option. So 0, 4, 1, 7, and 2, 2, 9, right there. Did I miss one? Something looks off. 0, 4, 5, 6, 7. Oops, and then 3, 6. Okay, what's going on here? My counting looks wrong. 0, 4, happy with that. 7, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, because I can't multiply. That's why. There it is. 3 times 2 is 6. 6 plus 4 is 10. Okay, and this is a good way of talking about this. I got a little bit excited. I got rolling here, and I made a simple mistake. And when I go and check with my table of values to my graph, I see something's wrong here in my graph, right in here. Okay, and so it happens. Everybody makes little mistakes sometimes. It's really easy. That's why it's good to have more than one way of solving these problems. So my 9 here isn't a 9. It should have been a 10. Okay, so now when I come over to my graph, this guy here that's plotted too low, it should plot a little higher, and see, now that starts to look good. And this is the importance of having consistency in all of your pictures, your tables. They should support each other. Okay, so if I draw that line, let's see if I can draw it decently freehand for now. There we are. Okay, so now we want slope. We have slope. 3 over 1, I could also get that from my graph. We want y-intercept. We have y-intercept. It's 0, 4, and I can get that from a couple locations. I can get that from here in my table. I can also get it from my equation. That's another place to find that. Now the last one's the tricky one, and you haven't done this one before, so we want to find an x-intercept. Okay, well an x-intercept is right here. Okay, so that is, come on marker, there he is. That's your x-intercept. Now, if we read it from the graph, we could see that it's negative. It's between -1 and -2. So I'm going to guess -1.5, 0. Okay, and that's my guess for my x-intercept. And when I'm doing an x-intercept from a graph, that might be the best I can do. Okay, and I'm going to show you on the next slide how you can do it really quickly and accurately with algebra, but when you're doing it from the graph, that might be as good as you can be. Okay, so there's our 3 pieces of information that were requested. Now I'll show you a slightly different way of doing this problem. So I want to find the x-intercept, y-intercept, and slope. So this is a strategy I use every single year, grades 9, 10, 11, 12. I write down x-intercept as the title. I know that every single x-intercept has a y value of 0. I take my equation and I substitute in a 0. That's an x. Okay, so now 3 times 0 is 0. So now I'm going to use my algebra skills to solve this little expression. So -9x equals 12. I divide both sides by -9, and I get x equals 12 over 9 can be reduced to -4 over 3, which is x equals -1.3 repeated. Okay, and then I really like to finish writing these with the actual coordinate. I think that's really important. Otherwise, people tend to forget what they're solving. So I would write this as -1.3, comma 0, and that is my x-intercept. Okay, and now if you compare that to our previous graph, okay, if we back up one page, we found an x-intercept of -1.5. So we were close, but not exact. The algebra method is exact, and that's what's really nice about the algebra. Okay, so now if we want to find our y-intercept, we're going to do the exact same idea, except I'm going to set x to 0. Okay, so I'm going to take my expression, and I'm going to start with 3y minus 9 times 0 equals 12. 9 times 0 is 0, so I'm left with 3y equals 12. Okay, I'll divide both sides by 3, and y equals 4. And again, I want to make sure I finish with a coordinate so I know what I'm solving. And you'll notice, here's the x piece, here's the y piece. Those two together give me the location 0, 4, which is my y-intercept. Okay, so now I can plot both of those on my graph. I'm going to show you a couple different techniques for finding slope. Oops, I put that one in the wrong location. That should be up here. Okay, I'll get rid of this little guy. Okay, and then we could draw our line based on those two locations. We could find our slope from our graph. I'm going to show you another technique in a day or two on how you can just use those 2 points. I always find just rearranging my equation is the easiest way for me to find my slope. So that tends to be what I do the most often. So again, my slope is right there. Okay, so that's another way of using your algebra skills to find x and y intercepts. Okay, there's no textbook homework, but I'd like you to try these 3 questions. Just like we did the last question, I'd like you to find the slope, the x-intercept, and the y-intercept for these 3 questions, please. And that's your practice work. Thanks for tuning in.